Right. So first of all, any questions about, okay, we talked about graphing, or they talked about graphing in this assignment yesterday. And we have a question about how to graph these things. Does anyone have any more questions about the first assignment besides the graphing portion? Okay, so let's go ahead and let's do a summary of the graphing. So this is your basic square root function, okay? Square root starts at 0, 0, the origin, and curves like this, okay? Now, the reason it's like this is, the reason it starts at 0, 0 is because you can't take the square root of a negative number, okay? You can't take the square root of, like, say, negative 16, all right? Now, we talk about reflections in mathematics. So what happens when we put a negative in front of a function? What happens when we put a negative in front of the x? It causes a flipping of the graph, okay? So the normal square root function looks like the way I graphed it right here, okay? This guy right here. Starts with 0, 0 and curves. When I put a negative in front of a function like this, it flips it across the y-axis. So remember, this is your y-axis, this is your x-axis. So putting a negative in front flips it across the y-axis. Okay. It's called reflections. So think about like folding a piece of paper and reflecting it. I'm sorry, no, why? My brain is not working this morning. I've not had a coffee yet. It flips it across the x-axis. Okay. Now, what I was intending to say, so flips across x-axis. Putting a negative in front of the x flips it across the y-axis. Okay. And the last thing is this guy right here. This flips it across both the x and y axis. Okay. So that's the main thing y'all need to know, okay, where the negative is. If the negative is on the outside, you flip it across the x-axis. If the negative is on the inside of the square root, it flips it across the y-axis. If the negative is both on the outside and the inside, you flip it across the x, then across the y. Okay. Any questions? Seth, did that make sense? You have to unmute yourself because you guys are all muted.
Yeah, it does.
Okay.
Because like he didn't even explain that. He just said, okay, square root x, and then here we flip it, and then boom, you're done. He didn't explain which ones went where.
Yeah. So this basically is a quick and dirty guide. So if the negative is on the outside, you flip it across the x. Negative is on the inside, you flip it across the y. If it's a negative, it's both on the inside and outside, you flip it across both.
Okay.
Ms. Humphrey, do y'all get it? Remember to unmute yourself. Ms. Humphrey, did y'all get it?
I get it.
Okay.
I get it.
Okay.
I do.
Ms. Paul?
I get it.
Okay. All right. Okay, so the first thing they talked about was, besides graphing, they talked about prime factorizations, what is a radicand, what is a square root, and what is a square root function. Okay, we already talked about prime factorization. Is there any questions about prime factorization? All right. And we talked about the properties of square roots. We talked about the product property of square roots that you can separate, the quotient property, and stuff like that. Do y'all remember how to do all of those? Okay, so let's do a quick example. How would we do 90a cubed b? Okay, anyone have an answer?
Is it 30a squared?
No. Remember, what do we do first?
You do the prime factorization, don't you?
No.
Oh,
Remember,
no, you simplify it.
yeah, you simplify, you separate. Remember, we separate the variables and the number. Now, we try to simplify 90. How do we simplify 90? Remember, we look for two numbers. How do we break down 90?
45 and 2.
Are 45 and 2 either of those perfect squares?
No.
Okay.
Hold up.
Remember, we separate these into two perfect squares. What are my perfect squares of 90? What factor is a perfect square of 90?
9 and 10.
Remember, a cubed separates into a squared and a.
Yeah.
And this is b. Now, 9, the square root of 9 changes to what?
3 and 3.
Okay. Okay, so remember, we can pull out the 3 from underneath the radical. A squared is a. So they stay the same way, b stays the same way. Now, which ones do we combine? Remember, the outsides get combined?
Yeah, on the inside. So 3a and then 10ab.
Everyone understand? Did y'all all forget how to do this? Hopefully y'all didn't forget all of this.
No.
Okay. One more. 45 m to the fourth, n to the fifth. Let's do that one.
Is it 3m squared square root 5n to the fifth?
Anyone else have something different? Okay, so let's walk through this. This is actually not, this is partially correct. It's not totally correct. So first, separate everything. Okay, now 45 separates into 9 and 5. Remember, I'm looking for factors, one of which is a perfect square, all right? And remember how we do a square root of a variable? We try to take, we find the even exponent, but m to the fourth already has an even exponent. Now, n to the fifth, we're looking for an even exponent. So remember, we separate n to the fifth to n to the fourth and n. Okay, so 9 becomes 3, square root of 5 stays the way it is, n to the fourth becomes m squared, n to the fifth becomes m squared, and 30 stays the same way. Now, when we combine the outside, and we combine the inside. That's really close, but not exactly.
I forgot the other part. That's the part I keep forgetting with the exponents.
Well, that's the purpose of these things, to jog your memory, because I know it's been a while since you guys have done this, and it's expecting for too much for any kid to remember all of this stuff. Well, you should, but you forget. I got 2 boys, and they dump information as well. So I know better. All right, now let's look at fractions. So remember, with these, we separate the numerator and we separate the denominator. Okay, and we do the same thing. Now, do y'all remember from my discussion, what do we not try to leave in the denominator? Anyone? Hopefully someone.
Isn't it like no square roots in the denominator?
Right. How do we get rid of the square root of 3 in the denominator then?
You square it?
No, you don't square it. Remember when we have a square root of the denominator, we multiply both the numerator and denominator by that square root?
Yeah.
And remember with multiplication, we multiply what's on the outside and we multiply what's on the inside. Y'all remember that?
Mm-hmm.
Okay. Is anyone still writing this or can I move on?
I'm still writing.
Okay. No, y'all gotta chime in because I'm not, if I don't hear anything, then I'm assuming that you guys are moving on. I mean, you guys are done.
I'm done.
Let's look at this one. Let's try this one. All right, so let's talk about this. So remember, the first thing we're going to do is we're going to separate everything in the numerator. And we're going to separate everything in the denominator. Now, how do I separate 45?
9 and 5.
9 and 5. Okay. And how do I separate p cubed?
P to the second and P.
Okay, now 16 is already a perfect square, so I'll keep it as it is. How do I separate a to the fifth?
A fourth and a square root, or square root A.
Okay, good. Now, square root of 9 changes to?
3.
Okay, p squared changes to?
P.
Okay, 16 changes to
4.
Now, combine the outsides. Combine the insides. Now, what do we have to do to finish this up?
Multiply both by 4a, or not 4a, a squared.
Any questions? Okay, remember to unmute yourself because you guys are all muted, okay? Because there's a lot of background noise. Okay. Anyone have
Good
any
morning,
questions?
Mr. D.
Hey, how are you doing? Does anyone have any questions? Okay. Now, let's look at adding and subtracting. When I add these, what do I get? Remember, how do I add radicals? Anyone?
Isn't it like, if it's the same, like, radicand, I think, that you just add the first two numbers?
Yeah, so as long as the radicals are the same, as long as what's underneath the radicals are the same, all you have to do is add the coefficients. So this is the same as 4 plus 2 root 3, which is 6 root 3. This is also the same with when we do subtraction. As long as the radicals are the same, just subtract the outside. Now, what if I have a problem like this? Now, normally you can't combine this because the radicals are different. But remember, what can I do with this 20? Remember I told you?
Simplify it.
Yeah, so how do we simplify 20? How do we break it up?
5 and 4.
Okay. And this 4 becomes a 2, so it's 2 times 2 root 5, which is 4 root 5 minus 7 root 5, and this gives you okay. So let's do an example. Okay, so how do I simplify this? Remember, we have to simplify when we can. So can I simplify 63?
Yes.
Okay, into what?
9 and 7.
Good. And can I simplify 28
Yes.
into?
4 and 7.
Good. So what comes out from the radical? The 9 becomes a what?
9.
Yeah.
3.
Okay. And the 4 becomes a?
2.
Good. Now remember, we multiply the outsides together. So 12 times 3 is?
36.
And 9 times 2 becomes?
8.
Can we subtract these?
Yeah.
And what do we get?
18 square 7.
Yeah. 36 minus 18 is 18. Perfect. Okay, what if I gave you something like this? Okay, so let's get started. How do we simplify these? So how can I separate 27?
9 and 3.
Mm-hmm. How do I separate 45?
9 and 5.
How do I separate 20?
4 and 5.
Okay, and how do I separate 48?
12 and 4.
Okay. So square root of 9 is
3.
okay. Square root of 4.
2.
2.
Okay, good. Now remember we can multiply the outsides. Remember to multiply, not add, okay? Are all my expressions simplified?
Yeah, but I don't get. Oh wait, never mind.
Is there? I think you can simplify one more.
Yeah, the 12. Like that's what I was looking at. Can't you simplify the 12?
Yeah. So what do you simplify? What can you break the 12 into?
3 and 4.
So we get finally 6 root 3 minus 15 root 3. I mean 15 root 5. Okay. Plus 8 root 5 minus 10 times 2 is 20 root 3. Now, which ones get combined?
The 3 and the 5, or 3 and the 5 and the 5.
Mhm. So this guy, 6 root 3 combines with negative 20 root 3, which gives me what? What's 6 root 3 minus 20 root 3?
Negative 14 root 3.
Okay. And negative 15 root 5 plus 8 root 5 gives me
Negative 7 root 5.
any questions? All right. Oh, can I move on? Is anyone still writing?
So, Mr. D, if we had another number that we cannot simplify instead of 12, we will just combine the fives and write the rest down like how they are.
Yes, because if the radical was different. So say for example, let's just say this was, I don't know, say that was the case, right? Just say, okay? Then you can't, then your answer, the only thing you can combine is these guys, because these are the only ones that have the same square root, okay? So then
Okay.
your answer would be, you just bring down everything else. So that would have been your answer if that was 13.
All right. Thank you.
Can I move on? Okay, so let's say, for example, I have something like this. How do I do that?
Don't you distribute?
Yeah, you just distribute like you do, okay? So remember, when you multiply, the stuff outside the radicals get multiplied and the stuff that's inside the radicals get multiplied. So when you distribute, remember, draw your rainbow if you need to. So this is Now, once you get to this step, you see if you can further simplify, but you can't. Okay, 21 can't get broken down, and since the radicals are different, you can't add them. So let's do something like this. Okay, so what do I get when I multiply 2 root 3 times root 21?
5 root 99 plus 2 root 63.
Now is where you simplify. Can I break down 63 into anything?
Yeah, 9 and 6. No, 7. Yeah, 9 and 7.
Okay, what about 99?
9 and 11.
Okay, so root 9 becomes 3. Then you multiply the outsides. Can I combine these?
No.
No. Right. Any questions? So this should give you a good jumping off point as to how to do the next couple of sections. And then tomorrow we're going to talk about adding and subtracting radicals, and multiplying radical expressions, and maybe basic equations. Any questions? Right, so if nobody has any questions, I will wish you a good luck on the rest of your assignments, and if I see you this afternoon, it'll be a pleasure. So, remember to,
Thank you, Mr. D.
you're welcome.
Thank you.
1 p.m. this afternoon. If you have any questions, please do not hesitate to reach out to me, okay? Remember, I'm here for you, okay? So I'm not doing anything.
We don't have to come at 1, right? If we already came to this.
Right, you don't have to come at 1.
Okay, got it.
But if you have any questions, and if you have any questions over the weekend, remember my first priority is to you. Just reach out to me. I'll answer any questions that you have. We can even do a one-on-one session if you'd like. So as you see, I can still teach like I do in class. Right?
See you,
Okay.
Mr. D.
So have a nice day.
You too.
You too, Mr. D.
Bye, Mr. D. Have a good day.
You too. Have a nice day, guys.
All right.